Hello, you are welcome to one of the most important physics lesson in your ordinary level science syllabus. That is the displacement time graphs. First, we have to identify what a displacement time graph is. Displacement time graph is the graph that illustrates how the displacement of a body varies with the time. It is drawn by representing displacement in y-axis and the time in x-axis. Let me draw a displacement time graph. This is a car that moving along a straight path by completing 2 meters of displacement in each seconds. The following table shows the variation of the displacement of this car. So let me draw the displacement time graph according to that chart. First we have to mark each axis and then we should mark each coordinates. Object moves 2 meters in first second and another 2 meters in second, another 2 meters in third, another 2 meters in fourth, and another 2 meters in fifth second. So totally the object moves 10 meters of displacement. Then we should draw a straight line by joining each coordinates. So this is the displacement time graph of above motion. Right, then we find the gradient of this graph. Gradient is the ratio between the difference of y coordinates and the difference of x coordinates. So in this graph, difference of y coordinates in 10 minus 0 and difference of x coordinate is 5 minus 0. So gradient 10 divided 5, that is 2. The displacement is represented in meters and the time is represented in seconds. So the unit of gradient is meters per second. So it is clear that the gradient represents the velocity of that object. So we can calculate the velocity of an object by finding the gradient of the displacement time graph of that motion. Right, let me observe another instance. So we can draw a shape of uniform velocity in displacement time graph. So that is represented by a straight line which is passing along the 0 coordinates. Then the shape of non-uniform velocity is a curved graph. Right? So uniform velocity is represented by using a straight line and non-uniform velocity can be represented by using a curved graph. Right. This car moves along a straight line 12 meters for the positive direction and then it moves back to opposite to the initial direction. Object moves 3 meters in each seconds and then it turns back and moves to the initial position. So if we mark these data on a chart, the object moves 12 meters for the positive direction and another 12 meters to the negative direction and came to the rest position, that is initial position. So let me draw the graph. So first should mark the axes and then mark the coordinates. Then by joining each coordinates we can draw the graph for first 4 seconds. That is a uniform velocity. After 4th second it turns back and moves to the initial position. That means the final displacement becomes 0. So let me draw a line joining each coordinates. So that is also a straight line, but the gradient is negative, right? So let me find the gradient of these two instances. So the gradient of the graph in first 4 seconds, that is the ratio between y coordinate, difference of y coordinates and difference of x coordinates. So that 12 minus 0 divide 4 minus 0, that is 12 divide 4, so it is 3 meters per second. So the velocity of first instance is 3 meters per second. And let me find the gradient of the graph in last 4 seconds. So that is the ratio between difference of y coordinates and difference of x coordinates. Difference of y coordinates is 0 minus 12. That means the difference should written by subtracting final displacement from the initial displacement. So in this case, the displacement, final displacement is 0 and the initial displacement is 12. So the difference of y coordinates is 8 minus 4. That means negative 12 divided 4. The answer is negative 3 meters per second. This negative sign represent that the object is moves opposite to the initial direction. Right. Let me draw another displacement time graph. Following chart represent the change of displacement of an object during 8 seconds. So according to this chart, you have clear idea. The object moves 16 meters in 4 seconds and then it does not move, but the time is wasting here. So let me draw the graph. In first 4 seconds, the object is increase the displacement up to 16 meters. And after 4th second, the displacement is not changed, but the time is wasting or time is passing. So that can be represented. In this case, it is uniform velocity, and after 4th second, it is a parallel line to the x-axis that represent the stationary or the resting position. Resting position. Right. Let me draw another displacement time graph. Following chart represent the change of displacement of an object during 10 seconds. So closely look to the data. In first 3 seconds, object increase its displacement by 5 meters in each second. And another 2 seconds it stay at that position, and after 2 seconds it start to moving opposite to the initial direction, and the displacement becomes 0 after 10 seconds. That means it came to the initial position after 10 seconds. So let me draw the graph. In first instance, it increased the displacement up to 15 in 3 seconds. And 4th and 5th seconds, it does not move and it is in resting position. And after that, it turns back and moves to the initial position and the displacement becomes 0. So this represents the uniform velocity, and this graph represents stationary or the resting position, and this also represents the uniform velocity. If we calculate the gradient in first 3 seconds and last 5 seconds, that is varies. Now, let me discuss some question related to the displacement time graph. Now, according to this graph, it asks how far has the object moved after starting from rest. So it moves 20 meters. It moves 20 meters along the straight path. Then second one, how long has it taken to travel the above distance? It take 4 meters. Sorry, it takes 4 seconds. And find the maximum velocity of the object during that period. So we have to find the gradient in first 4 seconds. So velocity is given by the gradient of the graph. So let me find the ratio between difference of y coordinates and x coordinates. So difference of y coordinates is 20 minus 0 and the difference of x coordinates is 4 minus 0. So the answer is 20 divided 4, that is 5 meters per second.